Example 3. A long wire carrying a current of 50 ampere is placed parallel to and 5 centimeter away from a similar wire carrying a current of 10 ampere. Okay, so let me draw this is wire X, and then it is 5 centimeter away from wire Y. Okay, so they're not carrying the same current. So okay, so we have to determine the magnitude and direction of the magnetic flux density at a point midway. Okay, so midway. Yeah. So this is gonna be okay. So this is the midway. I'm gonna draw a line just to show the midway lah. Okay. Okay, so when the currents are in the same direction and when they are in the opposite direction. Okay, so let me copy this, paste it here. So let's see when the current are in the same direction. So current is pointing up. Okay, and then for this one, wire X is pointing up, whereas wire Y is pointing down. So this is our current. Okay, now the first thing we'll be doing is we're gonna look at when it is in the same direction lah. Okay, so when they are in the same direction, firstly you have to draw the magnetic field lah. Okay, so the magnetic field, this one here, this one here. Oops. Okay, remember magnetic flux direction is tangent to the circle. Okay, remember that kejap, let me just draw this sampai sini, and then di sini. Okay, gitulah. Alright, so remember this would be anti-clockwise, and then this one. Okay, so pointing down, pointing down, pointing down, and then here. Okay, so remember it is the tangent, so I'm gonna draw just so that you can see. Tangent means how do I draw a tangent? Ini sikit lah, boleh nampak tak? This is BY punya. This is okay. So midway, this would be B untuk wire Y. This is for wire X. Okay. Always remember it is the tangent. Tangent. Remember kalau kita lukis gini and then the middle, tangent dia begini. Okay. Yeah. Gini lah. Something like this. Tangent. Okay. Then this one pun kalau direction dia begini, so tangent is something like that. BY. Okay, well harap boleh faham lah yang itu. Okay, so that is how you determine the direction of the magnetic flux. Actually, let me draw this easier in a much simpler punya drawing lah. Okay, so basically for what happened midway here is the direction of the magnetic flux for wire X is pointing up, whereas for wire Y it is pointing down. Itu je. Okay, so this is BX, this is BY. Okay, so and then we have the distance here would be 2.5, 2.5 lah. Sebab kita ambil the midway, which is the center lah. Okay, so this is our x, this is our y. Okay, so our x would be equal to ry, which is equal to 2.5 centimeter. Okay, boleh faham? There is 2. So what information we have is Ix is equal to 50 ampere. Current at wire Y is 10 ampere. And we have D lah just now, which is 5 centimeter. Okay, so we are going to use the equation for straight wire. So Bx is equal to mu naught Ix over 2 pi Rx, which would gives us 4 times 10 negative 4 Tesla. So the direction is into, no, I'm gonna write upwards lah. Okay, so the direction is upwards. Okay, and then By is do the same thing. And then you should get the value to be equal to 8.0, just 8 lah. 8 times 10 negative 5 Tesla, whereas the direction is downwards lah. Okay, right, so this is not the end of it, as we have to calculate the total magnetic flux density. Okay, so the total magnetic flux density for this is just the addition of these two. However, you should remember that magnetic flux is a vector quantity. So since before that, so the sign convention for magnetic flux is, if it is going out of the page, it will be a positive value. Okay, but if it is going into the page, it is gonna be a negative value. Okay, so sekarang ni which one yang out of the page is By. Okay, so By here is going out of the page, hence it will be positive, whereas Bx would be negative. So Bx would be negative 4 times 10 negative 4 plus dengan 8 times 10 negative 5. So this would equal to negative 3.2 times negative 4 Tesla, and the direction is negative, the value is negative, so the direction is into the page ataupun upwards. Okay, so for magnetic flux, if it is going upwards, it means it is going into the page. Okay, it is into the page, and if it is going downwards, then it is going out of the page lah. So this is downwards, and then this is upwards. Okay, terbalik kan ni? Betul lah, into the page. Into the page, upwards. Oh, okay, sorry, betul lah. Alright, so that's not it. Okay, so that is question A Roman 1. Now question A Roman 2 pula, we will be doing the same thing, except now the direction of the magnetic flux is different lah. Okay, so this is it, and then the direction for the magnetic flux untuk this one, guess I'm just gonna draw lah dia punya magnetic flux. Okay, so this one is dot, and then this one is x, and we have, take that. Okay, so this one's gonna be anti-clockwise, this one's gonna be clockwise. Okay, so the magnetic flux for this one, it is the tangent. So tangent meaning perpendicular to the, it's actually just like this one. Okay, perpendicular to the circle. So this one is gonna be like this lah. Okay, so this is Bx, this is by. Okay, so from there we can just directly calculate bx to be equal to 4 times 10 negative 4 Tesla as well. So this is the direction is upwards, and then by you will get 8 times 10 negative 5 Tesla juga, also upwards. Then you have to calculate bx plus by, and since both upwards, both are gonna have negative lah in front. Negative 8 times 10 negative 5, so this would be equal to negative 4.8 times 10 negative 4 Tesla. Okay, so this direction is upwards, which is into the page. Okay, alright, so that is question A. Now question B, we have to, when the currents are in the same direction, there is a point somewhere between x and y at which the magnetic flux density is 0. So how far from x is this point? Okay, so how far from x is this point? Okay, so untuk this question, both are gonna point in the same direction. So this one's gonna be pointing up lah. Okay, so from here we know that the magnetic flux density is in the opposite direction. So this is bx, this is by. Okay, so this is gonna be rx, ry, ry. Okay, so let's let rx to be equal to r, and then ry is basically just d minus r. Okay, we are trying to find this r because that is the point where the magnetic flux density is equal to 0. Okay, so when the total magnetic flux density is 0, we can let bx to be equal to by. Okay, so bx is mu naught ix over 2 pi rx, which is just so this one mu naught iy over 2 pi ry. Okay, so from here just substitute dulu, so you'll have cancel yang boleh di cancel, you are left with ix over r, iy over d minus r. Okay, so from here you should get r to be equal to 4.2 times 10 negative 2 meter. Okay, boleh. So that is the solution for example number 3.